right, another day must be more derivatives of exponential functions. So what are we going to focus in on today? Well, I'd like to look at some second derivatives, equations of tangent lines, and word problems. So first up here, I have an equation of a tangent line. How do we find the equation of a tangent line? Remember, to find the equation of a tangent line, we need a slope, and we need a point. Well, if I look at what I have, I'm given a point. I'm given my 1 and my 2. That's my x value, my x1 and my y1. The equation of the tangent line is y minus y1 equals m times x minus x1, equation of a line there. So we know y1 and x1, don't we? All we need to do is know what m is. Remember what m is. What is m? M is our slope. Slope of a line. Slope of the equation of the tangent line. That's going to be finding our derivative. So m is going to be the first derivative of this, and we're going to find the derivative of e to the x squared minus 1. Derivative of e to the x squared minus 1, we take the derivative of the exponent. So the derivative of x squared minus 1 is 2x. We'll multiply that by 2, which we get 4x. And then e to the x squared minus 1. Remember, the exponent of e will never change. So if you need to remember, we let that g of x equal the exponent, x squared minus 1. So our derivative was 2x. We multiply that to the coefficient, which gave us our 4x, and then e to the x squared minus 1. So we find f prime of the x value, which is 1. So we have 4 times 1, e to the 1 squared, which is 1, minus 1. That gives me 4 times 1 times e to the 0. Anything to the 0 power is 1, so I have 4 times 1 times 1, which is 4. So my derivative at 1, or my slope, when x equals 1, is 4. So my equation then is going to be y minus 2, the y value from my point, and that's going to equal 4, which is my slope, times x minus x sub 1, or my x value, which is 1. And I'm going to leave that. If we need to manipulate it, we can. We could multiply this 4 through, and we could add that 2 over. We don't necessarily need to, because we don't have to. Let's see here. We have a word problem. So here, the average energy consumption of a typical refrigerator freezer manufactured by York Industries is approximated by this kilowatt hours per year, where T is measured in years and T equals 0 corresponds to 1972. Notice that T is only between 0 and 20. So if 0 corresponds to 1972, then T equals 1 would be 1973. T equals 2 would be 74, T equals 3, 75, so on and so forth. So it's only going to work for the first 20 years after 1972. So if I ask you to find it for the year 2000, we can't do that because that's not in our domain. So be very careful with the domain and what they're asking us for. So part A says, what was the average energy consumption of the York refrigerator freezer at the beginning of 1972? So what was the average energy? Well, it tells us the average energy consumption of a typical freezer was approximated by this. So to find the average energy consumption for part A, I'm going to find C of 0, because 1972 corresponds to year 0. So if I plug in 0, I get 1,486 e to the negative 0.073 times 0 plus 500. 0.073 times 0 is 0. E to the 0 is 1. So I have 1,486 plus 500, which is 1986. Our units on this is in kilowatt hours per year. So kilowatt hours per year. And that answers our first part. So if it gives us the average, or it tells us what the consumption is or what the function is, and we're asking what is that, then we just plug in the value. Part B gets a little more complicated because it says how fast was the average energy consumption changing in 1975. So how fast? Now remember how fast. That tells us velocity, doesn't it? And whenever we see how fast something is, we're looking for the velocity, and the velocity comes from, you guessed it, the first derivative. So we're going to find the derivative of this. We will need our calculator today. So I'm going to go ahead and multiply that 1486 times, get down here so you can see it, 1486 times the derivative of that exponent, which is negative 0.073. And that gives us a negative 108.478 E. Again, that exponent will not change, so negative 0.073 T. And then derivative of 500, which is 0. And I can go ahead and find then for 1975. I'm not plugging in 1975 though, because year 0 was 1972. 1's going to be 73, 2 74, and 3 will be 75. So I'm looking for C prime of 3. So you get negative 108.478 E, so negative 0.073 times 3. Again, I can pull out my calculator. And we're going to go ahead and type that in. So we have our answer. So we could go ahead and recall that if you want. So our answer there times E to the negative 0.073 times 3. So I can go ahead and type all of that in there as well. So negative 0.073 times 3. And that gives me negative 87.143, if you want to go out 3 decimal places there. And what is our units? Well, it's in kilowatt hours per year, but since it's already a rate, we also need this. This is going to be for a year as well, so per year. So we're decreasing negative 87.143 kilowatt hours per year every year. And that gives us that answer. So the thing you got to remember with these is if it's asking how many or how much or what is, what was, that's going to go to the original function. If it's asking how fast, then it's asking for the velocity, and that's coming for the first derivative. So be very careful with your word problems there. Doesn't look like I have a second derivative problem ready for us to go, so I'm going to go ahead and make one up on the fly. So I'm going to give you f of x equals x squared. I'm going to ask you to find the second derivative of this. So the first thing we're going to do is find the first derivative. First derivative, e to the x squared. Derivative of e to the x squared. Well, find derivative of the exponent, which is going to be 2x. And then e, that exponent will not change. And then to find the second derivative of this function, I have a product rule. So I have 2x times e to the x squared. So product rule tells me the first derivative of e to the x squared, which is 2x e to the x squared. And to that we're going to add the second, which is e to the x squared, times the derivative of 2x, which is 2. And of course we're going to go ahead and simplify this. Something that we could do, we could multiply this, I guess, together. 2x times 2x gives us 4x squared, e to the x squared, plus I can rearrange that as 2e to the x squared. And then we can go ahead and factor out the common factor. So I have, again, that e to the exponent. We're going to see that that is in common, but we can also pull out a 2. So we have 2e to the x squared. And that's going to leave us with a 2x squared plus 1. And that'll be our second derivative. So that gives you an example of an equation of a tangent line, a second derivative, and a word problem, all in one day. How lucky can you be? You are the luckiest people in the world. Good luck, enjoy. If you have questions, let me know.